Hi, so in this video we're going to look at how we integrate through the method of substitution. So we use substitution when we have complex integrals, like for instance in this example here. So we couldn't use the reverse chain rule in this example, because when you differentiate 2x, you don't get x, you get 2. But we can still make this much simpler by letting a second variable u equal 2x plus 1. And we can rewrite this integral with u. So we have the integral of x multiplied by 2x plus 1, which is u, to the power of 4, and then dx. But now we have a mixture of x and u's. So we need to write this x and dx in terms of u. Well, we can begin with dx. We know that u is equal to 2x plus 1. So if we differentiate this with respect to x, we get du by dx, which is 2. So then therefore, dx must be equal to du over 2. So all we've done is we've moved the dx to the right side and then the 2 to the left side. So now we can substitute this expression for dx back into our integral. So we have the integral of x multiplied by u to the 4 dx, or du over 2. So the next thing is to write this x in terms of u, which we can do by rearranging u equals 2x plus 1 in terms of x. So x will equal u minus 1 over 2. And again, we can substitute this x now back into here. So again, we'll rewrite the integral. We have the integral of x, so u minus 1 over 2, multiplied by u to the 4, times, or du over 2. And we can simplify this by taking out the division of 2, and again, so this becomes a division of 4. And we can move this quarter in front of our integral sign. So we have the quarter of the integral of u minus 1 multiplied by u to the 4 du. And we can simplify it further by expanding out the brackets. So now we have 1 quarter times the integral of u to the 5 minus u to the 4 with respect to u. And can you see that this is a much simpler expression to integrate than this one? So we can integrate this. We get 1 quarter. We'll add 1 to the power, so u to the 6, and we'll divide by the new power. And this becomes u to the 5 divided by 5, plus the constant term. We'll expand these brackets out, so we get u to the 6 over 24 minus u to the 5 over 20 plus the constant term. And then we can substitute back in this u into each of the u's here. So finally, we get u to the 6, 2x plus 1 to the 6 over 24 minus 2x plus 1 to the 5 over 20 plus the constant term. So this is our final integral, okay? Let's try example 2. So in example 2, we've been asked to integrate x multiplied by 3x squared minus 1 to the power of 5 with respect to x. And we've been told that we can let u equal 3x squared minus 1. So again, we can rewrite our integral as x multiplied by 3x squared minus 1, which is u, to the power of 5, dx. So now we need to write dx in terms of u. Well, du, so if u is equal to 3x squared minus 1, then du by dx will equal 6x. So therefore, dx will equal du over 6x. And we'll substitute this back into our dx here. So we have the integral of x multiplied by u to the 5 dx, or du over 6x. Now can you see that this x here will cancel with this division here, and we can move this division of 6 out in front of our integral sign. So we have 1/6 times the integral of u to the 5 with respect to du. So now we can integrate this, which is far simpler than integrating all of that. So we get 1/6 of u to the 6 over 6. And we can substitute u back in as 3x squared minus 1. So we have 1/6 times the 6, which is 1 over 36. And then we'll substitute this u back into here. So this will be multiplied by 3x squared minus 1 to the 6 plus the constant. So we can simplify this as 3x squared minus 1 to the 6 over 36 plus the constant term. Okay? Let's try question 3. Okay, so in question 3, we've been asked to work out the integral of x times the square root of x minus 1 with respect to x. And we've been told to let u equals the root of x minus 1. So if you want to try this question yourself, you can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we'll do is we'll write this integral with this in place of u, with u in place of this one here. So we have the integral of x multiplied by u dx. And now we need to work out dx in terms of u. So u will equal x minus 1 to the half. To differentiate this, we'll bring the half down. So du by dx will be 1/2 of x minus 1. We'll take away 1 from this power, and then we'll multiply it by the derivative of the inner function, which is 1. So we'll leave it as this. And then we can simplify this as 1 over 2 times the root of x minus 1. And this is equal to du over dx. So therefore, dx will be equal to 2 root x minus 1 times du. But now we have a problem in that we've got an x term where we want it completely in terms of u. But we know that the square root of x minus 1 is u. So we can say this as dx is equal to 2u du. And it is this which we'll write back in terms of our integral. So we have the integral of x times u dx, which is 2u du. So now we can multiply the u and the u together to get u squared, and we can move the 2 to the front. So we have 2 times the integral of x u squared du. The next thing we need to do is to write this x in terms of u. So we can say if u is equal to the square root of x minus 1, then u squared plus 1 will equal x. And we can write this x into here. So we have 2 times the integral of x times the integral of x, which we know is u squared plus 1, times u squared, integrated with respect to u. We'll expand these brackets out. So we have 2 times the integral of u to the 4 plus u squared du. And we can integrate this as 2 lots of u to the 5 over 5 plus u to the 3 over 3 plus the constant term. So now we need to put this expression for u back into each of here. So we have 2 lots of root x minus 1 to the 5 over 5 plus 2 lots of root x minus 1 to the 3 over 3 plus the constant term. And this is our final integral. Okay? Let's try one more example. Okay, so in our final example, this looks a little bit strange in that we've been told that x is a trigonometric function and we've been given an algebraic integral. But we'll see what happens when we substitute this back into here. So we have the integral of 1 over the square root of 1 minus x, which is sine u, so sine squared u, integrated with respect to x. Now we can simplify this expression using the trigonometric identity sine squared u plus cos squared u equals 1. So therefore, cos squared u will be equal to 1 minus sine squared u. And then we can substitute cos squared u back into our integral. So now we have the integral of 1 over the square root of cos squared u dx. And now we've got this square root, and this square, these will cancel. So we have this integral of 1 over cos u dx. So now we need to write this dx in terms of u. So we know that x is equal to sine u, so dx by du will equal cos u. So therefore, dx will equal du cos u. And this is what we'll substitute back into our integral. So we have the integral of 1 over cos u dx, which is du cos u. And then these two will cancel. So our final integral becomes the integral of 1 du. And when you integrate 1 with respect to u, you just get u plus the constant term. But now we need to write u in terms of x. Again, if x is equal to sine u, we can work out u by taking the arc sine of both sides. And these will cancel. So u will equal the arc sine of x. So putting this back into here, our integral becomes the arc sine of x plus a constant. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from our website, mrmathematics.com. You'll find the link in the description below. Thanks again, and take care.